Our system of equations is 4x plus 3y equals 2 and 8x minus 9y equal negative 16. The general approach is we want to look for an equation where hopefully the coefficient in front is either 1 or negative 1 for a variable, but unfortunately we do not have that this time. So we're going to have to be a little bit more algebraically suave here. So what we're going to do is pick any equation, it doesn't matter which one, and solve it for the variable. So I'm just going to take the top equation, 4x plus 3y equals 2, and I'm going to solve it for either variable. I'm just going to pick x. So if I subtract, I get, oops, typo there, 4x equals 2 minus 3y. And now divide by 4. My suggestion would be it might work out a little bit better if you think of dividing everything that's added or subtracted by 4 individually. It's the same if you wrote the entire thing over 4. I just think this might be a little bit helpful in the form that we have it for completing the solution. Now, because then even I can see that 2 over 4, that simplifies to be 1/2 minus, and let me write this like this just so you recognize, 3y over 4. Remember, this is y over 1, so this is the same thing as 3/4 times y. Just make sure it doesn't look like y is in your denominator. So either way to write that is fine. We are going to have fractions to deal with, and the process is now we take this expression and we're going to substitute it in for x in the second equation, the one we haven't used yet. So that other equation is 8x minus 9y equaling negative 16. And we're going to replace x with the entire expression, 1/2 minus 3/4 y. And still minus a 9y equal negative 16. Definitely need parentheses here, because the 8 gets multiplied by all of x, not just part of it, so we're going to have to distribute. And at least now I can see that things are going to work out fairly nice, because when I distribute, I'm going to have 8 times 1/2 minus 8 times 3/4 y minus a 9y equal negative 16. And because my denominators both divide into 8 evenly, I'm going to be able to get rid of my fractions. So 8 times 1/2, remember this is the same as 8 over 1, so that's really just saying 8 divided by 2, that one becomes 4. Here, again, this is 8 over 1, so 8 times 3/4 I can think of as the 8 divided by 4 gives me just a 2. 2 times 3y is 6y, and now I don't have any more fractions. If I combine the y's together on this side, I get negative 15y equals, and let's subtract the 4 over to get negative 20. Now to finish solving for y, we're going to divide both sides by a negative 15. Looks like we're still going to have fractions, but we'll simplify. Of course, the negative and negative will make it positive. And 5 goes into both 20 and 15 evenly, leaving us with a 4 in the numerator and a 3 in the denominator. So y equals 4/3. 4/3 is a much better answer than trying to write that as decimal. And also, you don't have to write it as 1 and 1/3, just leave it as 4/3. That's fine. Okay, but that's only half of what we need, because we have also an x to find. So we're going to go back to the expression we had for x. We know that x is 1/2 minus 3/4 y. And we now know that y is 4/3. So x is 1/2 minus 3/4 times 4/3. Ooh, this works out very nice. 4's cancel, 3's cancel. Doesn't leave us with 0, of course. That leaves us with a 1. 1/2 minus 1 is the same thing as 1/2 minus 2/2, which is a negative 1/2. So we get 1 minus 2 being negative 1, and still a denominator of 2. So we have a y value of 4/3 and an x value of negative 1/2. If you're asked to put this as an ordered pair, that means coordinates of a point, which should be parentheses, the x value, negative 1/2, comma, the y value, 4/3. And always with a check, if you wanted to make sure that was right, You could put your two values for x and y into the two equations, and you should come up with two true statements. That would be your check.